Welcome to Huawei eLearning Services. My name is Wolfgang, and today we are talking about SDN OpenFlow Protocol description. After completing this course, you will be able to describe SDN OpenFlow Protocol. Here in this picture, you will see the OpenFlow development roadmap. So the OpenFlow Foundation has created the specification in 2010 with the OpenFlow release 1.0. Up to now, we have version 2.0, and within the last 5 years, the OpenFlow protocol has some special release functions in between with a lot of development steps. The driver for this OpenFlow protocol development in general and the SDN, the software-defined networking, was the highly increased traffic in the internet business. And to bring in more speed and better quality to this internet business, the OpenFlow Foundation has created this OpenFlow protocol. The OpenFlow architecture. In the OpenFlow architecture, you will see two main functions, the control function and the forwarding function. And there are two main roles defined here. One is the OpenFlow controller, who is responsible to control and to talk and to calculate all traffic-related functions to the switch. And the OpenFlow switch itself, he is responsible to execute commands to the devices, and he gets all the related information from the OpenFlow controller. So the evolution process of the OpenFlow was, here you will see the SDN network, and the evolution timeline you will see here again. So we started in the beginning that the OpenFlow protocol was just able to handle one OpenFlow table, and in this table there was the functions included to find, to process, and to forward some data packets in the SDN network. And in the release 1.0, we were also able just to handle one OpenFlow controller in this network, and we could also support IP version 4. In the following release development steps, a lot of more functions was developed. Normal functions when you know the normal IP network, but for SDN it was really a big step to have this function also included here. For example, VLAN tagging was implemented, MPLS function, multi-level flow table, IP version 6 were implemented from function 1.2, and a few more functions like more flow tables and more OpenFlow controllers, for example. So the specification, especially for the ports, there are two main points, the OpenFlow port and the flow table itself. For the OpenFlow port, there are three main ports defined. The first one is the traditional physical port. This is really the port visible in the device. Then we have a logical port, where we can define a logical function on the physical device port. And the last one, this is the OpenFlow defined port. This means we can define some port functions like you will see here, all, controller, table, import, any local, normal, and flood. And the last three here, the flood, the normal, and the local, these are also the ports defined in OpenFlow, where we have the OpenFlow hybrid switch functions included. And this you can compare with the normal OpenFlow switch function only. So the OpenFlow table. When you have some data packet in the OpenFlow and in the SDN network, then the switch and the flow table will be handled the data packet and will first collect some matching points. So if the the switch and the flow table will find the matching points. Then he will execute after that some task and some priority commands, together with some counter functions. This will be shown here. You will see here on the bottom the data packet divided in all the specific functions. And here you will see the functions like, first we have the match field. If the match field will found really the destination or the source MAC address in layer 2, then we go ahead with the task function and priority. We will do some forwarding, for example, or we do some modify in the fields. And we start also some counters that we have also some performance analysis here. So once again here for the flow table, there is some process table. Once again, we have a data packet. If there is some matching, yes, then we have these task actions to do something, also to activate the counters. And then we go to the table and execute the actions. If we did not have this, then we have the functions that we can go to a second flow table. And from the second flow table, we can go again to the execute all these functions. Or if also in the second flow table there is no matching, then the data packet will be dropped. The OpenFlow message exchange process. There we have different types. Here you will see the first. This is the channel establishment. In this picture you will see the switch and the controller. And before there could be any data packet could be executed or transmitted to any device, the switch first have to make an introduction to the controller and say, hello, I'm the switch with a number and his identity. And then after the hello, we can execute some feature requests and get some feature response, and then also some echoes when there are other tasks behind. Second one is the OpenFlow switch port information report. The meaning here, we have here a high secure tunnel established between the switch and the OpenFlow controller. And we have the function that we can do some multiple protocol tasks. We can execute some multiple protocol tasks. This could be done with some batches, for example. Then, yeah, we have also this function here. And the last exchange process is that we have the tunnel established, and the switch asks the controller with a packet in, but the controller responds, no, please flow modification, and the switch will this execute. So this was the flow model. Now we come to the distribution model. The distribution model, we have two types of distribution model. One will be an active mode, and this is the advanced one. And we have a passive mode, and this is the data planner driver. The meaning is, if we have the active mode, then the OpenFlow controller will always provide all flow tables to the switching devices, so that in every time the switching devices have always the right flow tables, like in the controller. If the received packet flow cannot match the existing flow table entries, then there are additionally two choices. We can discard it, or we can use the packet in option. That means that the switch will ask again with a request the OpenFlow controller what to do and what he should do with the data packets. Then we come to the passive mode. The passive mode means that if we have a packet and the switch do not know how to handle this packet, he will always ask the OpenFlow controller, and the OpenFlow controller answer with two informations. One is just execute a command. So the switch will then send and distribute some packets to a device. And the second information will be that the switch will also get told to store this destination address in his own OpenFlow table. So with this OpenFlow table, there are also some aging tables available. This means if there is with a certain time, 5 minutes, 10 minutes, no other request to reach the target, then after this aging time, the OpenFlow switch will delete after the aging time also this settings from the OpenFlow table. So if there is another request again, the switch will ask again the OpenFlow controller. So then we have the network switching model, and this means we have the OpenFlow controller and he's controlling everything. We have a very high secure SSL, high secure connection to the OpenFlow switch. And in the switch, we will have the OpenFlow table and the applicable programming interfaces to handle all the traffic with the single devices. So here you will see this. The OpenFlow controller has the connection with the secure channel of the OpenFlow switch. And then we have the flow tables, and this will be responsible for sending, receiving, and transmitting all the data packets to the devices. So this course focuses on SDN OpenFlow Protocol and introduces the following content: OpenFlow architecture, OpenFlow specification, OpenFlow table down distribution and modes, and so on. Thank you for watching.